All right, we're going to go over task card number 4. We're factoring out a greatest common factor. Oops, we're on question A. So I do know the greatest common factor between 20, 30, and 30. But if you did not, I wanted to show you again that strategy that you can use. If we know 2 goes into all of these, 2 goes into 20 10 times, it goes into 30 15 times, and it goes into 30 15 times. Now, looking at 10, 15, and 15, I know that 5 goes into both of these. I know it goes in 5 times 2 is 10, 5 times 3 is 15, and 5 times 3 is 15. Now 2, 3, and 3, those are all prime. Nothing goes into all, there's no greatest common factor of 2, 3, and 3. So then I would say, okay, my greatest common factor has to be 2 times 5. So our GCF here is 2 times 5, which is 10. You could have also just noticed that 10 was the greatest common factor to begin with, but I just wanted to show you that strategy. And then in terms of x's, we have 4 x's in the first term, 1 in the second term, and none in the third term. So we have no x's in common, no variables in common. So that means your GCF is 10, and then you need to multiply that by the 3 terms here to get your original expression, your original polynomial. Question B, we've got 27, 12, and 9. So I'm going to think about the number 9 first. I know 9 doesn't go into 12, it does go into 27. And then I'm going to start thinking of factors of 9. So I know that 9, the only factors besides 1 and 9 would be 3. So then I'm just going to check, does 3 go into all of these? Okay, so 3 does go into each of these. So our GCF, I know 3 goes into 9, it goes into 12, it goes into 27. And you can use that multiplication table on your packet if you want to, your toolkit, or you can use calculator. So GCF would be 3, and then we've got y squared for the first term. That's 2y's. Our second term has an x and 2y's, and our third term has 2y's. So in terms of variables that they have in common, well, they all have 2 y's in common. The x is not common with all of them. Only one of the terms has an x. So 3y squared would be the greatest common factor. And then you would want to know, what are we multiplying that with to get our original expression? So 27y to the second power divided by 3y to the second power would go here. Or you could also look at it as 3y squared needs to multiply with what to make 27y squared? On question C, we've got 40, 20, 50, and 50. They all end in zeros, so I know 10 goes into all of these. Is 10 the greatest common factor? So let's do 40, 20, 50, 50. Is 10 the greatest common factor? Well, let's take out a 10. If we take out a 10, 10 times 4, 10 times 2, times 5, times 5, yes. 10 is the greatest common factor. 4, 2, 5, and 5 have no other numbers that go into them that are common. And then just a reminder, with a greatest common factor, anytime your first term is negative, your greatest common factor is also going to be negative. So we do know that in terms of numbers, our greatest common factor is going to be a negative 10. And then in terms of your variables, you might want to, if you want to count out, you can. But imagine we have 11 in the first term, 11, write them all out. You've got 12 in the next one, 13 in the next one, and 14 in the next one. So what is the most that they have in common? And circle all the ones that they have in common. Okay. So yes, that would be 11. This has 11 x's. This has 11. This has 11, and this one has 11. They all have at least 11. That's what they have in common. Okay, but this one, I can't say the greatest common factor is x to the 12th because this doesn't have 12 x's. They all need to have at least that same number. Okay, so then you're just figuring out, okay, what do I multiply this by in order to get my original expression? So we've got negative 10 multiplied with what number to give us negative 40? x to the 11th. Oh, it's already x to the 11th, so that would stay x to the 11th. Okay, so like first term here would just be a 4. And then we've got a negative 20 divided by a negative 10. That should be positive 2, so plus 2. And we have 11x's here. We need 12, so we need one more. So that's kind of your strategy here. Then you need your last two terms here to complete this. For question D, we've got greatest common factor between 8 and 4. Well, 4 goes into 8, so 4 would be the greatest common factor. And then, so 4 goes into both of these. And then in terms of the variables, we have x to the third, that's 3x's y squared. And we have x to the third in the second one. So in terms of what they have in common, they really only have these x's in common, and they've got 3 of them. So 4x to the third is what they have in common. And then you'll multiply that by, you have 2 terms here. And then our last one, we've got 28, 14, 35, and 7. So typically I'll look at the smallest number, see if it goes into all of them. Well, it goes into itself, it goes into 35, I know it goes into 14, and I know it goes into 28. So 7 is your greatest common factor here. And then in terms of the variables, I'm going to let you figure out what your GCF is. We've got a B, we've got B's, 2 B's, then we've got 3, and then we've got 5. What is the greatest number that they all have in common? And then put that here, and you can finish the expression for that.